Oh,
Oh, cool. Can you guys see my screen okay?
Yes.
Perfect. When it starts, let me know if you can't hear it, so I can fix that. And we are recording. All right, let's get started. So good morning, everyone. We are the University of South Florida American Institute of Chemical Engineers. I am Jacob Lajeunesse, here with my partner, Sebastian Irizarry.
that's my name.
And we have prepared a video of some experiments that we thought you guys would find pretty interesting. So without further ado, let's start the video. So real quick, if anyone has any questions or anything, feel free to put them in the chat or raise the hand. I think today we're going to take a second after each of the experiments and just go over what we saw again and see if there's any questions that you guys would like for us to answer, or we can watch the experiment again, or whatever you guys want. Hi everyone, we are the USF chapter of the American Institute of Chemical Engineers. We are very excited to be showing you these demonstrations. Before we start though, we want to go through one very important thing, and that's safety. If you notice in the videos, all of our experimenters have on lab coats as well as pants and gloves. And when the experiment calls for it, they have on their safety goggles. These are a crucial part to keeping us safe in the lab and are a major part of all college laboratory class courses. While some of these experiments do not appear to be dangerous, please do not attempt them at home. They have been performed by trained adults who have hours and hours of laboratory experience. Thank you and enjoy the video.
Hey guys, this is the Coke and Mentos experiment, and this is a test of CO2 inside a soda. See, what happened is whenever you open soda, you hear the fizz come out, and that's all the CO2 being released all at once. So what we're going to do now is going to test all the what's going to happen if you mix Mentos and CO2. What's supposed to happen is that the Mentos is going to react with the CO2 and create more and more bubbles, and then it just keeps bringing it out, and we're going to see that right now. Let's get a little. That's better.
That was better.
Go.
So I just want to take a quick second and pause the video and say I know that that's a pretty classic experiment, but a lot of people don't know that it is actually caused by a chemical reaction inside of the soda with the CO2 inside, and it causes it all to bubble up so fast that it can't leave the soda, so the soda overflows and explodes everywhere. But that's one of my favorites.
One more thing. I would say the Mentos acts as a catalyst. Catalyst is something that speeds a reaction up. It just forces all the bubbles inside the Pepsi to go up fast, like get out of the liquid really quickly into the atmosphere. That's a magical thing about a Mentos. Fun fact.
All right, let's continue.
Hi everyone, I'll be performing the balloon blower experiment today.
So in this plastic bottle, we got baking soda mixed with water. And now I'm going to pour some vinegar on it. See how it expands? So this is happening because there's a CO2 reaction happening inside the bottle, similar to the one you saw before with the Mentos. So this is how it looks after a while, and this is very similar to the way you blow up a balloon on your own, except we're doing it with a chemical reaction inside our bottle. Hi, today I'm going to be doing a rainbow milk experiment. I'm going to add food coloring to milk, and then when I add a touch of soap, the soap is going to scare away the fat molecules and the color is going to spread. Got it. Got it.
So this one is also one of my favorites. Just a quick note about it. So if you see in the supermarkets, you'll see like whole milk, reduced fat milk, things like that. That is dependent on the content of the heavy cream in the milk, which is very fatty. So water and fat don't like to mix. So when we use this dish soap, we touch it to the actual milk in the center of the color. And because the water and the milk or the water and the fat don't like to touch, they spread apart very fast. And that's what causes this really awesome rainbow looking reaction in the milk. All right. I think this one is so cool how it just explodes apart just from the tiny touch of dish soap with a Q-tip.
Alright, hey guys, I have two flasks here, one with regular tap water and one with fine metal iron powder here. And what I'm going to show you now is the really cool power of a magnet, what you could do, even with, it's going to be dirty water. Please do not drink this, do not try this at home, because it's not very safe. But right now, I'm going to mix the two. So what right now I have is a very strong cohesive mixture. That's called a homogeneous mixture. That means it's very mixed, very thoroughly mixed through. It's very difficult to separate by hand. So what I'm going to do is show you the power of this magnet. And as you know, magnets and iron go together really well because iron loves to go towards the magnets. So how magnets work is that they have two poles, a north and a south pole, and those poles generate a little bit of electricity so that it pulls the iron shavings towards it. So eventually.
So before we show you guys the final outcome for this one, I just wanted to note that when we actually mixed the iron shavings and the water together, the water was so metallic that it caused the magnet to stick to it. So it was actually so attracted to the water that it stuck to the bottom of the beaker. And really, when we mixed it all together, it was dark black. You could not see a single thing through it. And just after maybe 2 minutes with the magnet on the bottom, it really cleared up. So I'd like to show you guys the final product.
So now, as you can see, all the precipitate, which is what we call the little dirty stuff in the water, has settled all the way to the bottom. And now you can see all this clear water. I would say not safe to drink still, but it is a lot better than what it was before. So, toast.
Hey everyone, so we're going to be doing the slime experiment. So in this red bowl, I have the main chemical for slime, borax, and then hot water, and then food color mixed together. And I went ahead and stirred it. And then in this bowl here, I just have a mixture of glue and water. All right, now we're going to go ahead and mix the two bowls. together to everything is evenly applied in this bowl. All right, we're gonna go pull it out, and this is what we have as a final product. Very sticky, very stretchy, and fun to play with. So, if you're ever feeling stressed out, you can use this as a nice little just squeeze ball, and then squeeze it, and slime.
Hello everyone. So today we'll be doing the fire bubbles experiment. So what I'm going to do is some nice bubbles here. Partner has his trusty lighter. So what we just saw, there was a flammable gas right in the soapy water. And then when combined with heat, it created a combustion reaction. But luckily, my hands are fine. Because the soapy water acted as an insulator.
So I think out of all the experiments that we ran, this one was definitely my favorite. I just think it's so cool how, you know, like if you watch the video, he's literally holding the fire in his hands as it lights up, and then just a quick flick of his hands and it's all gone. I'll replay it one more time for us to watch. So he gets a nice handful of bubbles that are actually filled with the flammable gas, and he dips his hands in the water to make sure they're nice and wet and insulated.
Has his trusty lighter.
And they just light it up right in front of him.
So we just saw, there was a flammable gas.
So you can imagine you just blowing a regular bubble, but instead of putting just your breath in it, you put propane,
because the soapy water,
flammable gas.
All right, everyone. I hope everyone enjoyed the video. If anyone has any questions, please feel free to put them in the chat. Sebastian and I will be glad to answer. If not, we actually have a giveaway where we can give away 2 prizes. We're going to ask 2 questions, and the first person to put the answer or speak up and shout it out will get the giveaway. So we have 2 of those. Take one more second and just see if there's any more questions for the chat. All right. So this first question comes from the rainbow milk experiment. I will skip back to that. And the first question is, I will put it in the chat as well. So the question is, what causes the rainbow spreading effect in the milk in the rainbow milk experiment? So if you remember back, there were a couple different ingredients, but one in particular on the end of the Q-tip. Nice try. Not quite. So we will watch the video one more time. So listen close.
I'm going to add food coloring to milk.
That's the food coloring that goes in the milk.
When I add a touch of soap, the soap is going to scare away the fat molecules and the color is going to spread.
Very nice. The fat with the dish soap. Great answer. All right, I have a link to claim your prize. One moment. All right, please click the link in chat and fill it out, and we will get in contact to get you your prize. Great job. So our next question comes from the classic slime experiment. So I will take a few different answers for this one. So there are a few main ingredients in this slime. I would like you to name one of them. I will take a few different ones. So let's watch the video one more time and we'll hear what the main ingredients are again.
So we're gonna be doing. Hey everyone, so we're gonna be doing the slime experiment. So in this red bowl, I have the main chemical for slime, borax, and then hot water, and then food color mixed together. And I went ahead and stirred it. And then in this bowl here, I just have a mixture of glue and water.
All right, did you guys hear it? There were a couple different things he said. Yep, 7 Rivers, coming in strong. Great answer, guys. So there's that link one more time. Fill it out twice so we can send you guys your prizes. So I would have taken glue, I would have taken hot water and borax. The only thing I would not have taken would be the food coloring, because that was just to have a cool USF colored slime as the final product. All right, guys. If there's any questions or anything for Sebastian and I, please put them in chat. We will stick around for a few minutes afterwards if you want to see another part of the video. Yeah, we do too. It was definitely a lot of fun in person. We can't do so many experiments related with fire inside, which are the best ones, most definitely. All right, guys. Hope to see you next year in person. We will be back and better than ever. Go Bulls. Bye.